Hello, pre-calculus students. This is Mr. McAllen, and today we're going to talk about quadrantal angles, but in radians. So what we're going to do is we're going to talk about how to work with these angles um, when they're in radians. But first, let me just demonstrate what we did when we did not have a quadrantal angle and how we recognize its reference angle. So in our first problem, we're going to just review how to find a normal trig ratio using radians. Remember what we did in yesterday's video was we looked at the bottom number of the simplified radian fraction. We saw that it was a 3, and that told us that 5 pi over 3 has a reference angle of 60 degrees. We drew our triangle in the correct quadrant, so we figured out from the whole ratio that 5 pi over 3 was roughly, if you estimate it, was roughly 5 radians. 5 radians puts you at, that's 0 radians. The vertical line is at 1.5 radians as you go around clockwise. Then you're at 3 radians, 4.5. So we are in quadrant 4. And because it's a 60-degree reference angle, I'm going to draw my 60 there. I'm going to have negative root 3, and I'm going to have positive 1. So when I do the sine ratio of 5 pi over 3, my ratio is going to be negative root 3 over 2. So this was pretty simple to do, especially because we've been doing so much work with using our reference triangle and finding our trig ratios. And now we're recognizing certain clues that radians give us when we're working with special angles around a circle. So we're going to explore how to do this using radians, but for quadrantal angles. So first thing I want to inform everybody about is this was approximately 1.5 radians. It's also pi over 2 radians exactly. So we're at 0 when we're on the x-axis. When we come around to 90 degrees, we're actually at pi over 2 radians, the exact amount. Here we're at pi radians. Then when we continue around, we're at 3 pi over 2 radians, which is approximately 4.5 radians. And then we're back to a 2 pi radians for a full revolution. Now, if we keep going on our next revolution around, you'll see something that happens. The next one is going to be, this will be 5 pi over 2 radians. As we keep rotating around, we're going to now be at, this would be 3 pi. We keep going. Now we're at 7 pi over 2 radians, and then we're back again at this, and we're at 4 pi. So what I want you to notice is there's a pattern going on. If you have a simplified radian fraction, when you have a 2 in the denominator, you are basically on the vertical axis. You're either at 1.5 radians or 90 degrees, or you're at 270 degrees, depending on what the number is. Like, let's say you're at 3 pi over 2. You know you're on this line, but 3 pi over 2 will bring you to 270. So that, and if you're at 0 or at pi or at 2 pi or at 3 pi, as you go around the circle, whenever you have a 1 in the denominator, that's a sign that your reference angle is 0 degrees, or you're on the horizontal axis. So these are clues that we want you to take advantage of. And remember what we did when we were using degrees and we had to worry about our quadrantal values. We knew that sine had a pattern that went from 0 to 1 to 0 to negative 1 to 0 again. The cosine ratio went from 1 to 0 to negative 1 to 0 to 1. So we're using this table that we had before, and the tangent just went from 0 to undefined, 0 to undefined, 0 to undefined. And the reason why tangent did that was because tangent is known to be equal to the sine ratio divided by the cosine ratio. And we're using that to help us figure out all the values here. And this is old lesson material that we've talked about in one of our earlier videos. But now we want to extend the knowledge to radians. So I just want you to see, if I do above here, if I just write in radians, I'm going to just change the color of the ink so we can see that better. I'll just put it in black. This would be 0 radians. This would be pi over 2. This would be pi. This would be 3 pi over 2. and this would be 2 pi. So anytime you have a denominator that's a 1, that 1 indicates that you are on the horizontal axis. So you would be using the values from the table of 0, 180, or 360. If you have a 2 in the bottom, let's say 3 pi over 2, then you are on the vertical axis. So how do you know which way you're pointing? Pointing up or pointing down, pointing left or pointing right? Again, that comes back to estimating where you are radian-wise. So if you get, let's say, the sine of 3 pi over 2, what you would do is you would recognize that you're on the vertical axis, but now you need to know where you are in the circle. So this is 0 radians, and from looking at what we did before, this radian amount is approximately 4.5 radians. So that puts you right here at 4.5 radians from what we did before. And that would tell you that you are at a 270-degree angle. Here's 3 pi over 2. The sine ratio from your chart would equal -1. Let's just go over this one more time. Okay, so yesterday we learned that the bottom number has a lot to do with where we are for our reference angle. We tried things out, like if you had 5 pi over 3, you knew your reference angle was equal to 60. If I gave you 5 pi over 4, that 4 indicated your reference angle is equal to 45. And if I gave you like 7 pi over 3, let's just say 7 pi over 6, the 6 meant the reference angle was 30. Well, now we're extending it and we're saying, well, if you have, let's say, 7 pi over 2, then you know your reference angle is equal to 90 degrees because the 2's in the bottom. You're on the vertical. You just need to know which way you're pointing. So you estimate 7 pi over 2 by saying 7 times 3 divided by 2. That gives you about 21 over 2, or 10.5 radians. So you go around the circle, you're at 6 radians. Then all the way down to here, this is 10.5 radians. And you would know you'd line up with about the downward pointing vertical axis. It would be the same angle value as 270 degrees. So you'd be using that column. So that is the essence of our lesson. So let's just do an example. Let me say that if you were given the cosine of 3 pi, then you would recognize that because of the reference number underneath, you're on the horizontal. So you're either pointing this way or pointing that way. So 3 pi tells you you're about 9 radians. So when you think about 9 radians, you go from here to here, you're at 3, then you're at 6, now you're at 9. You're at the same place you were when you were at 180 degrees. You look up at your chart for the cosine of 180. Your chart says that you're at a -1 trig ratio, and that's how you figure out the trig values at quadrantal angles. What I'd like you to do is I'd like you to try these out. I have a few problems for you that are going to be on the form. I'd like you to try them out. And to get credit for the homework, you need to answer those questions on the form, and we'll talk about it tomorrow. Thanks for watching, and look forward to hearing your comments on how to find trig ratios of quadrantal angles in radians.